Hello guys, welcome to my channel again. Today I'm going to give you an overview and implementation description about kidney and its tumor segmentation. These days, deep learning algorithm getting so much popularity, and with the available of large set of data set, algorithm getting more and more accurate, enhancing. There are many libraries publicly available also. So, one of the major improvement has been seen so far in terms of medical data set that the diagnostic of tumor can be done much more efficiently than the human. So, with the aim of this, this improvement, recently in 2019, kits dataset is also made publicly available. So when I encountered this dataset, I thought I should create a video about it. So you can learn about the challenge on the main page. There are link of the dataset URL will be given in the description section of the video. Let me move quick to the main part. Okay, so this dataset is consisting MRI images, and every MRI images is in an easy format, along with the segmented part of kidney and the tumor portion. I'll show you how the NIZR dataset will look like, and thereafter I'll move toward the segmentation implementation, which is being done on PyTorch. So for getting the dataset, when you will click on this link, you will be redirected here where its dataset GitHub link is available. When you click on the link, you will see Git repository here, and all you need to do, just run few lines of command from here. Then you can clone the repository, move toward the kits inside dataset, then pip install requirement.txt file. I believe you guys already have basic knowledge of Python. So yeah. And then for downloading the dataset, you require to run this command. Let me show you. I have already downloaded the dataset. I'm showing you for demonstration purpose. When you run this command, it will start downloading the dataset like in this way. Okay, there are 90 images available in the dataset. You can download it. Let me show you how the dataset will look like once you complete the downloads. So here my dataset cases are available. Okay, let me open one of the case for you guys. So this is one of the case which consists image and segmentation NIZR format. For visualization in the local computer, you cannot see NIZR images directly. You require a tool to which enable you to see the images. So I'm using Mango here. There are other tools also available. So let me open the tool for you, and then we'll show you how the image will look like. It's important you to understand the image demonstration first, because for creating the algorithm, you must understand the dataset first, what is your required task and how it should look like. Thereafter, you can create the algorithm successfully. So I have already opened the Mango tool. Let me reach out to that directory. Click on open image. And click on kits. Then let me open one of the case for you. So I'm going to open imaging first, and then the kits segmentation part. Okay, so let me show you how you can visualize the data set. Like, let me reach out to the both kidney portion, like in this way. Now these are visible pretty much. Okay, and let me align them. I guess I'm done now. So guys, you can see here, this is the input image and this is the segmented image. You can see here Okay, the both the this is the side view, so only one of the kidney will be available. This is the front view, or both the kidneys will be visible, and this is also the horizontal front views where you can see both the kidneys. Okay, the white portion you can see here is the tumor portion. Ultimate goal of the challenge is to create such an algorithm which will be able to identify the kidney from these images, and thereafter would be able to locate the tumor portion inside the kidney. Okay, when I click on the tumor portion, you can see on the windows on the right top, this represents a second class. The first class is the kidney, and 0 class is the background. So your goal is to first segment the segment the images, and thereafter classify into 3 classes. Okay, so this data set is available in the 3D format, but due to the consistency of the data set number of layers, okay, first you first need to create an algorithm which convert 3D data set into 2D format, and thereafter, okay, perform the segmentation, and later on reconstruct the 3D images from the 2D segmented part. Okay, so let me give you the overview of the data set prior to let me show you how the train and mask images will look like. So from those 3D images, you convert the 2D images in like this. Okay, so there are many slices available. Once you convert the 2D images, there will be almost 2,90,000 number of 2D images will be there, and the train mask, corresponding train mask is not visible like in the 2D format, because these masks consist only the 3 classes 0, 1, 2. So for visualizing the mask, you can only see in the notebook. Okay, so this is the main final notebook I have created for you guys. Let me give you an overview in a very quick manner. Okay, these are the libraries. I'm using FastAI, which is built on the top of PyTorch. You can also download FastAI by running this command like pip3 install FastAI, and your FastAI will automatically download it. Okay, yeah, here you can see my requirement is already satisfied, so I don't need to rerun this code. Okay, let me move it forward. Here I'm loading the dataset. My entire images are available in the dataset folder, so I'm walk through the dataset, then get the name of the dataset, writing those images in CSV file by converting the pandas data frame, where it consists the directory name, the file name, the segmented directory name, and the segmented file name. Okay guys, once I have this data set in the form of CSV format, so let's move forward from here. This is the function for loading the NiJet image. There is a library available which is enable you to reading the NiJet images directly, Nibble. Okay, you can download this library the same way, pip install Nibble, and then you give the path of the library. Every files will be available in the data frame. So whenever nib load will read the NiJet files and then convert into the numpy array thereafter. Okay, you will have the array of files from NiJet from the NiJet format. Let's move toward this is for visualizing one of the images. So let me show you few images. Okay, that will be help you to understand better. So you can see here, this is one of the image, okay, from the sample, which is already being converted into 2D format with the filter method, which is available in the FastAI. I'm using custom filter method because FastAI hasn't been developed the kidneys filters, kidney data set filtering method. So I'm using custom method for here to visualize the image. This method is being created for plotting the samples. Here you can see the multiple samples are being plot. This is the original image. This is the window image. You can see in window image the kidney portion is quite visible. This is the mask from the segmented, and this is the kidney mask where the mask is overlay on the main image. Okay. So this is for check whether how many number of classes are available in each mask. Okay, this custom method is created for pre-processing of the data set and save the data set in the JPG format, which I already show you here. Okay, moving toward the next section, this will be the JPG that I have already shown you. This portion, this is a very important portion where basically we are generating the data set for training purpose. Okay, so we actually reshaping the image so that it consume less memories, only taking the single band of image from the segmented portion, and the input portion consists all the 3 bands. Okay, here you can see background, kidney and tumor are the classes which we require, which we need to locate ultimately from each input image. Okay, why I'm using the fast AI? Because fast AI already consists the UNET learner. I have already make videos about the UNET description. The DLS is the method where we actually call the data loader. So this data loader work much efficiently than the storing the image, all the image in the workspace first, and that consume lot of memory. So this data loader help to save the memory and enable us to train on the data set. Okay, I'm using pre-trained Resnet weight. So in the UNET, the pre-trained Resnet 18 is act like an encoder method where pre-train as Resnet 18 already being trained from large number of image data set. So that's the thing. So Resnet 18 will act as an encoder, encode the image. Cross entropy flat loss is used for use as a loss function, which give the highest accuracy in most of the cases of UNET learner, where we have multiple classes and input 2-dimensional images. So this is how the model is pre-trained model is being created here. This is available already into fast AI. Okay, then as already pre-trained weights on the encoder of Resnet 18 is available, it won't take much time to optimize itself. Here you can see when we perform the training, there is a train loss and validation loss will get display, and the training time is almost is very less. That means training complexity is very low, and it takes around 36 seconds to complete one epoch. Okay. With the PyTorch fast AI, you guys also will be able to see the top 50 predictions, how it look like. Okay, so there is a plot top losses built-in method is available. Okay, from the segmentation interpreter. So here you can see the input image target and the predicted loss. So top 50 losses means on those images where we achieve the minimum loss, so can be visualized. Here you can see input image target and predicted loss images. Okay, this is the original and this is the predicted image. Okay, so move toward, you can save the pre-trained weights and use it further. I have also created a prediction method on the test data set, where you can see original image, window image, mask and kidney overlay on the predicted images. You can see here how the some of the images will look like when we perform the prediction on test data set. This is the original window image, mask image, where this portion is represent the tumor on the kidney, and this image will represent the same way, where this predicted image is superimposed on the original image and it look like this. Okay, here few samples are made, few slices from one samples are made visible. So this is all about kidney tumor segmentation. This is the 2D plot of segmented image. Okay guys, I hope I try to explain you better. If you want further understanding, the number is given on the internet, where one of the data scientists can take the dedicated session for you and explain you further in-depth functionality if you would like to understand. This is all about. I hope you guys, if somebody is actually want this source code, just ping me on WhatsApp. My number is available, okay, and you can get the copy of the source code. Okay, thank you guys, thanks for watching this video. Next time there are multiple versions of medical data segmentation will be available shortly, and in any domain you are pursuing PhD on the same in the similar type of field, you can contact us. Thank you guys, love you all, bye.